People usually start by saying time is what a clock measures. That sounds sensible. It also explains absolutely nothing. It is like saying a length is what a ruler measures. You have not told me what length is. You have only pointed at an object and said, look over there. So let us not pretend we understand time just because we own clocks. Here is another favorite line. Time is the flow from past to future. Flow like what? Like water? Like air? Where is it? Flowing at what speed? If time flows, does it take time to flow? You see the problem. The explanation eats its own tail. So let us be more honest. We do not start with time. We start with things happening. A pendulum swings. A heart beats. The earth goes around the sun. A cesium atom jiggles in a very particular way. We notice that some happenings are regular. They repeat. When something repeats reliably, we grab it and say, good, we will use you to keep track of everything else that is a clock. Not because it knows time, but because it does the same thing again and again. Imagine you are alone in the universe with one bouncing ball. It hits. The floor comes back up, hits again. You can count the bounces. 1, 2, 3. Do you have time? Sort of. You have order. You know which bounce came before which. But if the ball slows down and stops, your time falls apart. You had no backup. So, you build a better clock. You use a pendulum or a spinning wheel, or today an atom that flips its internal state billions of times per second. You are not discovering time. You are inventing a bookkeeping system for change. Now, here's the first uncomfortable thing. Different clocks can disagree. Take a wristwatch and a pendulum clock. Carry one up a mountain and leave the other at sea level. Bring them back together. They will not quite agree. That is not philosophy. That is experiment. The atomic clock on a GPS satellite must be corrected, or your phone would tell you that you are driving through a lake. So, whose time was right? You might think one of the clocks was broken, but both clocks did exactly what they were built to do. The world itself did not let them agree. This is where people invoke Einstein like a magic spell. They say, according to Albert Einstein, time is relative. That sentence is true and useless unless we understand relative to what? Einstein did not say time is an illusion. He said something far more disturbing. The rules that connect one clock to another depend on motion and gravity. That is a physical statement, not a poetic one. Before we get there, it helps to remember that even Isaac Newton thought time was strange. He assumed a universal time ticking away, the same everywhere, but he could not explain what was doing the ticking. He just assumed it worked. So here is the puzzle we are heading toward. If time is built out of change and different, changes disagree about how fast they change, then what exactly is time made of, and why does nature refuse to give us a single universal answer? That question is where things start to get interesting, and also where your everyday intuition quietly breaks down. Let us try to be very concrete, because time becomes slippery the moment you let words do the work instead of events. Imagine a long train moving smoothly down a track. No shaking, no noise, just gliding along. There is a person sitting exactly in the middle of the train with a clock on the platform. Another person is standing still with another clock. Both clocks were built the same way. Both were carefully checked. Nobody cheated. Now, lightning strikes the front and the back of the train at the same moment. According to the person on the platform, 2 flashes, equal distance, same time. That sentence sounds innocent. Same time. But what does that mean? It means the light from both flashes reaches the platform observer at the same instant. And after correcting for distance, he says they happen together. Fine, but the person on the train is moving toward one flash and away from the other. Light does not care about your opinions. It always moves at the same speed. So the light from the front strike reaches the person on the train before the light from the back strike. He does not say, well, I am moving, so I will correct it the other way. No, he uses the same rules, same kind of clock, same assumption that light travels at the same speed in all directions. He concludes that the front strike happened before the back strike. Which one is wrong? Neither. This is the part that makes people uncomfortable. The disagreement is not about bad clocks or slow reactions. It is about the structure of the rules themselves. The idea that there is a single universal answer to the question, what happened at the same time, simply does not survive contact with experiment. People often, this means simultaneity is relative. That is true. It also explains nothing, unless you feel the discomfort of it. Here is the key point. Time is not just a label we attach after things happen. It is tangled up with how information travels. In our universe, information travels at a finite speed, mostly the speed of light. Because of that, when you try to compare distant events, you must make assumptions about how signals move. Those assumptions are not optional. They are built into how clocks are synchronized in the first place. Einstein realized this by being very stubborn about operational meaning. How? Do you know 2 clocks are synchronized? You send signals, you receive signals, you make rules. Once you do that, Honestly, the idea of a universal now evaporates. You can try to save it by inventing a hidden master clock ticking behind the scenes, but then you have to explain why no experiment can ever detect it. At that point, you are not doing physics anymore. You are doing bookkeeping for your own comfort. So, instead of one time, we get many times. Each observer carries their own clock along their own path through the world. That path is called a world line. Along that line, the clock ticks, and that ticking is as real as anything else we measure. What is strange is not that. Clocks disagree. What is strange is that nature insists they disagree in a very precise, predictable way. There is a strict mathematical rule connecting them. It is not chaos, it is geometry. Once you see that, a new question appears. If time depends on the path you take through the world, then time is starting to look less like a background stage and more like part of the scenery itself. And that raises an even more unsettling question about what space and time really are when you stop pretending. They are separate things. At this point, people usually say, fine, time depends on motion. That is weird, but I can live with it. And then they quietly keep thinking of space over here and time over there like two separate boxes. That is where the real misunderstanding hides. Here is the trick nature is playing. You cannot actually separate space and time without lying a little. Take a simple trip. You walk across the room. That sounds like pure space, but it takes time. Now stand still. That sounds like pure time, but you are still moving, not in space, but through something else that behaves suspiciously, like a direction. You are always moving. The only question is how you divide that motion between space and time. This is where Herman Minkowski came along and said something that sounded abstract, but was really very practical. Space and time are not separate things glued together. They are parts of a single structure. We call it SpaceTime. But the name is not the important part. The important part is that motion through. This structure has a fixed total amount, like a budget. Let me make that concrete. Imagine you have a car with a speedometer that always reads the same number. You can spend that speed going north or east, but the total is fixed. If you go more north, you go less east. If you stop going east entirely, your speed is north. In our universe, everything moves through space-a-me at the same total rate. Light spends all of it. On space, it goes as fast as possible. Spatially, and for it no time passes at all. A clock sitting on your desk spends all of it on time. It does not move in space, so it moves fully in time. You Walking across the room split the difference. This is not philosophy. This is a calculation that matches. Experiments. When a clock moves fast through space, it must slow down in time. It has no choice. The budget has already been spent. Now think about the famous twin story. One twin stays home. The other flies off in a fast spaceship and comes back younger. People argue endlessly about acceleration and turning around. That is a distraction. The real reason is simpler and deeper. The two twins take different paths through SpaceTime. One path is straight, the other is bent, and just like in ordinary geometry, different paths between the same points can have different lengths. In space-time, the length of the path is the amount of time the clock experiences. Time is not something happening to the clock. Time is the length of the clock's path. Once you see that, the argument stops being emotional. It becomes geometric. You do not ask which clock is really right. You ask which path is longer. Now, here is where things get truly unsettling. If time is a kind of distance, and distance depends on geometry, then whatever bends. Geometry is going to mess with time itself. Motion already does that. But motion is not the only thing that bends paths. There is something else that curves space-time in a way that no amount of clever clock building can escape. And when you see what it is, you realize that time does not just depend on how fast you move, but on where you are standing. Up to now, we have been blaming motion for all the trouble. Move. Fast, your clock slows down. Fine, that already hurts the head a little, but you can still picture it. Then gravity shows up and refuses to be ignored. Here is the thing people say: gravity pulls on time. That sentence sounds deep. It is also dangerously vague. Pulls how? With what hands? So let us start smaller. Imagine you are inside a closed elevator in deep space, far from anything. No gravity. The elevator is suddenly accelerated upward. You feel your feet press into the floor. If you drop a ball, it falls to the floor. Everything behaves exactly as if you were standing still on Earth. Now imagine the opposite. The elevator is sitting on Earth, not accelerating at all. You feel your weight. Drop a ball, it falls from. Inside the elevator, there is no experiment you can do to tell whether you are accelerating in space or sitting in a gravitational field. This stubborn equivalence was taken seriously by Albert Einstein. And once you take it seriously, you are in trouble in a very productive way. Because if acceleration affects clocks and acceleration is locally the same as gravity then. Gravity must affect clocks too. So let us build a thought experiment. Put one clock on the floor and another clock on the ceiling of the elevator. The elevator is accelerating upward. Light sent from the floor to the ceiling has to climb while the ceiling is racing away. When the light arrives, it is stretched. Its frequency is lower. That means the clock at the ceiling ticks faster than the one at the floor. Now, replace the accelerating elevator with a stationary building on Earth. Same effect. No hand waving, same physics. The clock closer to the ground ticks more slowly. This is not a metaphor. It has been measured. Put one atomic clock on a mountain and another at sea level. Bring them back together. They disagree. GPS. Satellites experience weaker gravity than you do. So their clocks tick faster. Engineers must correct for this, or your location would drift kilometers per day. So gravity is not a force pulling on clocks. Gravity is a distortion of space-time itself. The geometry we talked about before is no longer flat. It is curved, and clocks follow that curvature whether they like it or not. Here is the unsettling part. Two identical clocks sitting still relative to each other can age at different rates just because they are at different heights. No motion, no acceleration, just location. So the question changes again. We are no longer asking how fast time passes. We are asking why space-time has the shape it does. What is it that tells space-time how to curve? And why does that curvature show up to us as gravity, falling apples, orbiting planets, and slow clocks near massive things? Once you ask that honestly, you're only one step away from realizing that time is not a background ingredient of the universe at all, but something that emerges from the way the universe is built. And that realization opens a door to a problem we still do not know how to close. Now we are forced to ask the question we have been tiptoeing around. If space-time curves, what is doing the curving? You cannot just say gravity, because that is the very thing we are trying to explain. That would be like saying opium makes you sleepy because it has a dormitive virtue. It is a label, not an explanation. So Einstein asked it the hard way. What physical thing tells space-time how to bend? The answer he arrived at is both simple to say and hard to swallow. Energy and matter determine the geometry of space-time. Not push it, not pull it, determine it. Space-time responds to what is in it. If you put mass somewhere, space-time near, it is no longer the same as space-time. Far away, distances change, times change, Straight lines are no longer what you thought they were. This is why planets orbit, not because the sun reaches out and yanks them, but because the straightest possible path incurved. Space-time happens to be a loop. The planet is doing the laziest thing it can do. It is just following the geometry. Here is a useful picture, and also a dangerous one. People draw a rubber sheet with a bowling ball in the middle. Smaller balls roll toward it. That gives you some intuition. It also lies to you because it sneaks in gravity from outside the picture to explain gravity inside the picture. So do not take it too seriously. The real point is this: what we experience as gravity is not a force acting in time. It is the shape of space-time itself, and time is one of the dimensions being shaped. Near a massive object, time does not behave the same way it does far away. Near a black hole, the effect becomes extreme. From far away, you would see a clock near the hole ticking slower and slower, never quite stopping, but coming arbitrarily close. For the clock itself, nothing special happens at that moment. It ticks along normally. So, whose time is right? Again, the question dissolves. Each clock measures the length of its own path through space-time. There is no master timekeeping score. Now notice something odd. All of this treats time as something continuous and smooth. You can stretch it, bend it, slow it down, but it is always there like a rubber fabric. But when we look closely at nature in another domain, the quantum domain, everything else stops being smooth. Energy comes in chunks. Light comes in quant. Atoms have discrete states. So here is the tension. Our best theory of space-time says time is a smooth geometric dimension. Our best theory of matter says the universe jumps in little steps. What happens to time when space-time itself must obey quantum rules? Nobody knows. This is not a failure of imagination. It is an experimental fact. We do not yet have a complete theory that tells us what time really is at the deepest level, and that forces us to consider a possibility that sounds outrageous at first, but keeps coming back no matter how hard we push it away. What if time is not fundamental at all? Here is where the ground really starts to wobble. We have been talking as if time is something out there, bending and stretching and slowing down. But all of that assumes time exists in the same way a ruler exists. And when you try to combine gravity with quantum mechanics, that assumption becomes suspicious. In quantum mechanics, you do not start with time as an object you can poke. Time is something you feed into the equations from the outside. You say, at this time the system is like this. At a later time, it is like that. Time is a parameter not a player. In general, relativity time is the opposite. It is part of the system. It bends, it reacts, it has dynamics. You cannot glue those. Two ideas together cleanly, they fight. So some people have begun to suspect that time is not fundamental, that it is more like temperature. Temperature feels basic. Hot and cold feel real. But temperature is not a thing by itself. It emerges from the motion of atoms. If you zoom in far enough, temperature disappears. Could time be like that? Think about a deck of cards. You shuffle them. You deal them out. There is an order. But the order is not stored in the cards themselves. It is a relationship among them. Change the relationships and the order changes. Now, think about entropy. This is one of the few places where time seems to have a direction. Glasses break, they do not. Unbreak. Eggs scramble, they do not. Unscramble. That direction is not built into the microscopic laws. Those laws mostly work the same forward and backward. The arrow of time comes from statistics, from the fact that there are vastly more disordered arrangements than ordered ones. When you start in a special low entropy situation, the most likely future is toward disorder. So, maybe what we call time is really a bookkeeping device for change in complexity. There is a radical idea that follows from this. Maybe the universe does not evolve in time at all. Maybe it just is a four-dimensional structure. Past, present, and future all sitting there together. What we experience as the flow of time is just how our brains move through correlations inside that structure. That idea makes people nervous. It sounds like it kills free will or change. But that is just emotional reaction, not physics. Physics does not care how ideas make us feel. The real question is operational. What can be measured? What can be predicted? So far, every experiment we can do fits perfectly with the idea that clocks measure the length of paths in space-y. None require time to be a flowing substance. None require a cosmic now. And when we try to push deeper, the equations stop talking about time at all. That is not because time is mysterious. It is because time may not be there to talk about. If that is true, then the deepest question is no longer what time is, but why we experience it the way we do. And that brings us to the final step where physics quietly hands the problem back to us. So here we are at the end. And the strangest thing is that time has slowly slipped out of our hands. We started by trying to define it. That failed. We replaced it with clocks. Then we discovered clocks disagree. Then we learned that the disagreement is not a flaw, but a feature. Time depends on motion, then on gravity, then on geometry, and finally, when we tried to dig underneath everything, time stopped appearing as a fundamental ingredient at all. And yet, here you are listening to this feeling. Seconds pass. That is not an illusion, but it is not what we thought it was either. What you experience as time is tightly tied to memory. You remember yesterday, not tomorrow. You remember breakfast, not the future. That asymmetry is real, but it does not come from the fundamental laws. It comes from entropy and from how your brain records information. Your brain is a physical system. It forms memories by increasing entropy elsewhere. Heat is dumped. Energy is dissipated. You cannot remember the future because the physical process of memory formation only works in one direction, not philosophically, thermodynamically. So the flow of time is not something happening to the universe. It is something happening to you. A clock does not feel time pass. It just ticks. A rock does not notice the future approaching. Only systems that store records and compare them to the present have anything like an experience of time. This is why the present feels special, not because the universe labels it as now, but because that is where your records stop. The past is full of information. The future is not. That as symmetry creates the sensation of motion. So when you ask what time really is, the most honest answer we can give right now is this: time is how change is, counted by physical systems that, remember, at the deepest level we know, the universe may simply exist as a web of relations. No flowing river, no ticking cosmic clock, just structure, geometry, correlations. And inside that structure, there are little subsystems, like you following particular paths, building memories, calling one direction past and the other future. That is not a disappointing conclusion. It is a precise one. Physics did not remove time. It relocated it, and the final irony is that the more carefully we understand time, the less mysterious the universe becomes, and the more mysterious it is that we are here at all asking the question in the first place.